हेलो एवरीवन। ग्रेविटेशन का पार्ट 2 आज सेकेंड डे का ये क्लास है जिसमें आज मैं डिस्कस कर रहा हूँ आप लोगों के साथ वेक्टर फॉर्म ऑफ न्यूटन्स लॉ ऑफ ग्रेविटेशन। वी कैन राइट न्यूटन्स लॉ ऑफ ग्रेविटेशन. दिस इज न्यूटन्स लॉ ऑफ universal law. This is Newton's law of universal gravitation. In vector form, as F12. What is 1, 2? I will state about all things. This one is the formula according to formula minus G M1 M2 upon R square, but there is R21. You can write R21 square of this one, and the unit vector of R21. Now we will discuss all the parts which we are applying here. What is R21 and what is RF12? Where F12 is the force on mass M1 exerted by mass M2, which is at a distance R21. R21 away, and R21 is the unit vector. This R21 I am going to write here R21, and the cap of this R21 is the unit vector that point from M2 to M1 along the line joining their center. I discussed with you what is F21. So F21 is the force on mass M1 exerted by the mass M2, is at a distance R21. R21 I will also show the R21 here. So what is R21? You can see from here. This is the distance from M2 to M1, है ना? So R21 cap I am written here already. R21 here is the unit vector that point from M2 to M1. That means you are taking the distance from M2 to M1. This is the actual distance along with the vector sign. Here is the vector sign, unit vector. This is a R21 cap. What is R21 cap? So R21 cap is R21 vector sign upon magnitude of R21. What is R21? So I am writing here also R21, where R21 is where R21, this above portion R21, and the vector sign is the displacement vector. This one is the displacement vector, and this one is represented in figure 1 as I shown here, and the minus sign, negative sign, is necessary since it is since the force on M1 due to M2 point in along the direction is in the direction of R21. I'm mentioning here this negative sign in equation 1. This is the above equation,
Sir,
and there is a negative sign minus. So negative sign in first is necessary since the force on M1 due to M2 points in the direction opposite to R21 कैप. ये जो वेक्टर्स हैं इसके अपोजिट डायरेक्शन को दिखला रहा है ये. और नेक्स्ट वन द डिस्प्लेसमेंट, जो डिस्प्लेसमेंट वेक्टर है, द डिस्प्लेसमेंट वेक्टर ये R21 जो आपके पास डिस्प्लेसमेंट वेक्टर है, डिस्प्लेसमेंट वेक्टर R12. अब मैं R12 के बारे में बात कर रहा हूं. तो ये जो डिस्प्लेसमेंट वेक्टर है, मेजर कंफ्यूजन बच्चों को यहीं पे होती है. मैं फिर से रिपीट कर रहा हूं. दिस इज R21 is a vector of same magnitude. This is the displacement vector of same magnitude as R21. मतलब जिस तरह की मैग्नीट्यूड R212 की होगी, सेम मैग्नीट्यूड R21 की होगी, और बट द डायरेक्शन विल बी ऑलवेज इन अपोजिट, so it should be in opposite direction. By Newton's third law, the force F21 acting on M2, this is M2, acting on M2 due to M1, this is M1, must have the same magnitude as F12 but acts in opposite direction. You can write F21 is equal to minus F12, and this one is equal to G M1 M2 upon R21 square of this one and the unit vector of R21. Similarly, you can write for F21 is finally minus G M1 M2 upon R12 square of this one and the unit vector of R12. This is the just opposite sign. You can see here it is in negative, and there is no negative, that means there will be positive sign, that means both are in opposite direction as we shown in here. One thing is also markable, that the law of universal gravitation should not be confused with Newton's second law of motion, which is F equal to ma. The gravitational force of attraction and how its value varies with distance and masses involved. On the other hand, Newton's second law relates the force on a body. It can be any force to the mass and the acceleration of the body. After that, we will discuss the expression for acceleration due to gravity.
सर एक बार लास्ट वाली स्लाइड दिखा दो, स्क्रीनशॉट लेना.
Okay, beta, consider there is a earth. This large sphere is a earth, and this small sphere is the any mass object, small mass object. So you can write here, consider earth to be a sphere of mass. This one is represented as ME and radius RE. Suppose a body of mass small m is placed on this small m is placed on the surface of the earth as shown in this figure. The mass of this earth is me, and obviously the weight of the body acting vertically downward, and this weight you can write here W equal to mg, and the radius of the earth is represented as re. According to law of gravitation, the force of attraction on the body due to earth is given by F equal to G mass of earth me, and the second mass is small m, which is mass of the object which is placed over the surface of the earth, and the radius re square of this one. Consider this is equation 1. This attractive force which the earth exert on this object is simply the weight W equal to mg of the object. Then you can also write that F equal to mg. This is equation, you can consider the equation 2. And now from equation 1 and 2, from 1 and 2, LHS side both have F are equal, so you can write here mg equal to G mass of earth into mass of object upon radius of earth square of this one, and here you cancel small m both side, then you get the value of capital G small g is equal to G m e mass of earth, small m already cancelled from here, so replace, and re square of this one. So this is the, you can say also that this is the relation between small g and capital G. That means this gives the expression for acceleration due to gravity on the surface of the earth. As you have seen here that the value of g, small g, does not depend on the mass. Small mass already you cancel from here, तो ये g small mass पे depend नहीं करता. And the next is thus the two bodies of different masses are allowed to fall freely. They will have the same acceleration. If they are allowed to fall from the same height, they will reach the earth simultaneously. But it must be remembered that there will be no air resistance between these two bodies which are freely fall from the same height. Second point, both capital G and mass of earth me are constant, and re is the radius of the earth, does not change appreciably for a small variation in height near the surface of the earth. Therefore, we can say that acceleration due to gravity of an object near the surface of earth approximately constant and does not depends on the mass of the object. That's why we are taking 9.8, the value of g, small g, on the surface of the earth. And the third point, we can easily extend equation 3, which is the relation of small g and capital G, to find the gravitational acceleration gravitational acceleration or at the surface of any planet of mass mp and radius rp. That means it's not only for the earth, it's also for any planet, applicable for any planet. Small g is inversely proportional to the square of the radius. As we know that the earth is not a completely sphere, it's a oval shape. So there will be the variation in the radius. You can say that this one is the, you can write this one is the radius of the pole, and this one taken as the radius of equator of this earth. If you are taking an object at the pole, obviously you can see here that the radius of pole is less than the radius of the equator, and it is almost 21 kilometer less than radius of equator. So if we are talking about the radius of pole, you are writing a GP inversely proportional to the radius of the pole, square of radius of pole, and for equator GE inversely proportional to the radius of the equator, square of the radius of the equator. Which one is greater, GP or GE? So obviously, this one have the small value, so GP is greater than G, and that means acceleration due to gravity at pole must be greater than the acceleration due to gravity at equator. When you multiply m both sides, you can write mg p greater than mge. एक चीज तो ये क्लियर हो जाती है. It is clear that weight of a body at pole must be greater than weight of the body at equator.